Today we are going to break down some of the most important theoretical concepts in transportation planning and travel demand forecasting. These are concepts that, appear repeatedly in MSc exams, form the backbone of transport modeling software, and really define how professional transportation engineers think. So don't just listen, understand the logic behind each idea. Let's begin. Let me start with a simple question. Do all households generate the same number of trips? Of course not. A family of 2 without a car behaves very differently from a family of 6 with 2 cars. And that is where cross-classification analysis comes in. Cross-classification analysis is a trip production modeling technique that groups households into categories based on key socio-economic characteristics, such as income, household size, and car ownership. Instead of treating the population as one average group, we classify households into cells, and for each cell, we determine an average trip rate. Now, how do we develop a family of cross-classification curves? First, we identify the most influential household variables. Second, we divide these variables into discrete categories. Third, we use household travel survey data to calculate trip rates for each category. Finally, these rates are represented as tables or curves for easy application. Why is this important? Well, because it captures realistic variations in travel behavior, improves forecast accuracy, and reflects non-linear relationships that simple models just cannot capture. That is why cross-classification is, widely used in urban travel demand forecasting. Now let me ask you this. Once trips are produced, how do they decide where to go? This is the role of trip distribution, and one of the most powerful tools here is the gravity model. The gravity model is based on a very intuitive idea. Trips increase with the attractiveness of destinations, and trips decrease as travel time or cost increases. Just like gravity in physics, the model assumes that the total trips produced and attracted by zones are known. Travelers prefer shorter and easier trips, and travel behavior is stable under similar conditions. Now, what about friction factors? Friction factors represent travel resistance. They reduce the number of trips as travel time, distance, or cost increases. In simple terms, friction factors tell the model, the farther or harder the trip, the fewer people will make it. This makes the gravity model behaviorally realistic. So why do we use the gravity model so much? First, it reflects real human behavior. Second, it can use different impedance measures. Third, it is flexible and adaptable. Fourth, when calibrated, it matches observed travel patterns very well. In short, it balances simplicity and realism, which is why it dominates trip distribution practice. Let's move forward. Once trips know where they are going, the next question is, how will people travel? This decision is called mode choice. Mode choice, well, it refers to the process by which travelers select a particular mode, like car, bus, rail, walking, or cycling, for a given trip. This decision, depends on several factors: travel time, travel cost, comfort, reliability, income, and of course, personal preferences. Mode choice is extremely important because honestly, it directly affects things like traffic congestion, public transport demand, energy use, and even environmental impact. Now, let's talk about how we estimate transit usage. There are 3 major procedures. First is the aggregate method. This uses broad indicators like population density and employment levels, and it's especially useful for early planning stages. Second is the trip-based method. Here, transit demand is estimated by applying mode choice models to trip tables. Third is the system-based or network method. which considers route coverage, frequency, and network performance. Each method really has its place depending on data availability and the planning stage. Sometimes planners need answers quickly. That is where the Quick Response System, or QRS, comes in. QRS is a simplified method that estimates mode shares using elasticities derived from observed data. Instead of building full models, it starts with base year mode shares and then adjusts them based on changes in time, cost, or service quality. QRS is ideal for short-term planning, policy testing, and rapid evaluation of alternatives. Let's talk about zoning. A study area is divided into traffic analysis zones, or TAZs, to simplify analysis. When defining TAZs, engineers consider land use homogeneity, socio-economic similarity, physical boundaries, administrative boundaries, travel patterns, zone size, and network accessibility. Good zoning, honestly, improves model accuracy. So, transportation planning is not meant to give one final answer. Why is that? Well, it's because the future is uncertain. There are multiple objectives to consider, and, honestly, trade-offs are just unavoidable. Planning is really there to support decision-making, not to enforce a single decision. The core of travel forecasting actually consists of 4 steps: trip generation, trip distribution, mode choice, and traffic assignment. These 4 steps together form the famous 4-step model. So, the process starts with land use and socio-economic data. Then, it moves through trip generation, trip distribution, mode choice, and traffic assignment. And finally, there's evaluation and feedback. Just remember, this process is iterative, not linear. Mode choice models include aggregate models, disaggregate models, logit models, and nested logit models. Each of these offers, increasing behavioral realism. Finally, let's talk about utility. In mode choice modeling, utility represents how attractive a mode is. When we add amenities like comfort, reliability, safety, and reduced waiting time, we increase the utility of that mode. This directly affects traveler behavior and mode share. If you understand these concepts, you are not just preparing for exams. You are thinking like a transportation engineer. And honestly, that mindset is what separates students from professionals. I am Engineer Hamza, otherwise known as the Meticulous Engineer. This channel is dedicated to bringing you core engineering education and principles. If you like what I am doing, do well to support me and subscribe to my channel.